Hello everyone, this is Neha CS studying first year MSc in JSS College, Ooty Road, Mysore. My seminar topic is Basic Principle of Electron Spin Resonance Spectroscopy. Before going to the principle, we should know about spectroscopy. Spectroscopy is the study of interaction between the matter and electromagnetic radiation, and it is used to measure the energy difference between various molecules' energy levels to determine the structure. Electron spin resonance is also called as paramagnetic resonance, and it was discovered by the physicist Zavoyevsky in 1945. And the spin is a net result of the angular momentum of all nuclear particles is called as electron spin. And these particles also have the properties to spin in their own axis, and each of them possess angular momentum of h by 2 pi, and it is a vector quantity. Electron spin resonance spectroscopy is a branch of absorption spectroscopy in which radiation having a frequency in microwave region is absorbed by the paramagnetic substance, and electron spin means electrons field angular momentum. And this ESR is not shown by every molecule, it is shown only by the free radicals having unpaired electrons, and for the transition metal compounds, atoms having odd number of electrons, ions having partially filled electron shells, molecules that carry angular momentum of electronic origin, molecules with a paired electrons and zero magnetic field. Examples are NO, O2 and NO2. The principle of ESR is the phenomena of electron spin resonance is based on the fact an electron is charged particle. It spins around its own axis and it act like a tiny bar magnet. When the molecules or a compound with unpaired electron is placed in a strong magnetic field, the ESR spectrum results due to the transition between the energy levels by absorbing radiation of microwave frequency. These spin unpaired electron can align into two different ways, creating a two spin state, that is ms is equals to plus or minus 1 by 2. The alignment can either be along the direction that is parallel to the magnetic field, which corresponds to the direction of the lower energy state, that is ms is equals to minus 1 by 2, or it may be opposite to the direction of the applied magnetic field, that is ms is equals to plus 1 by 2. The two alignments have different energies, and it is given by the equation delta E is equals to h nu, which is equals to mu g beta naught, where h is the Planck's constant, v is the frequency of radiation, mu is the Bohr magneton, and beta naught is the strength of magnetic field in Tesla, and g factor is the unitless measurement of intersonic magnetic momentum of the electron, and value of the electron is 2.0023. And it is the energy level diagram. Here the ESR signal is due to the transition of electrons from the spin state, that is ms is equals to minus 1 by 2, to the spin electron state, and ms is equals to plus 1 by 2. The spin state may interact with the magnetic moment of nuclei with which unpaired electron may partially or fully associated. These interaction may lead to the splitting of resonance signals into the several lines. This is called as hyperplane splitting. These are some examples under ESR. First one is CH3. Here the carbon is having a radical and having a lines, that is 4 lines. We can obtain this value by using the equation 2ni plus 1, where n is equals to 3 and I is equals to 1 by 2, and n is the number of hydrogen atoms and I is the spin of hydrogen. By applying this n and I values to 2n I plus 1 equation, we get 4 lines. Similarly for CH3 and CH2 molecule, here this will split into two types. There are CH2 and CH3. N1 is equals to 2 and I1 is equals to 1 by 2 for CH2 molecules. N1 is equals to 2 because there are 2 hydrogen atom, and N2 is equals to 3 because there are 3 hydrogen atom, and the spin of hydrogen is plus 1 by 2. So the total number of lines is equals to 12. And it is the another one example of inorganic molecule. Here the I is equals to 3 by 2 for copper and I2 is equals to 1 for nitrogen, and having the N1 and N2 value of 1 and 4. When you apply these values to 2Ni plus 1, we get totally of 36 lines. So let us discuss some questions. First one is, what is the difference and similarities between electron spin resonance and nuclear magnetic resonance? ESR and NMR. In ESR, chemical shift is absent, but in NMR, chemical shift is present. The transition between electrons occurs upon the absorption of quantum of radiation in microwave region. The transition occurs upon the application of radio frequency in NMR. The frequency required is 800 meter per second inverse in ESR, and the frequency required is 40 meter per second inverse in NMR. The similarities between NMR and ESR is, both the method use angular momentum, that is pure spin or total momentum of in ESR spectroscopy, molecules in a state containing unpaired, that is with a non-zero spin angular momentum, are placed in a constant magnetic field. Likewise, in NMR, the composite system of nuclei in a molecules with a non-zero nuclear spin is placed in a constant magnetic field. Which electromagnetic radiation is used in electron spin resonance spectroscopy? Here we use weak radio frequency radiation, which is in microwave region. What is electromagnetic radiation? It is the kind of radiation including visible light, radio wave, gamma rays and X-ray, in which electric and magnetic fields vary simultaneously. Next question is, explain why the electron spin resonance spectroscopy shows plus 1 by 2 and minus 1 by 2 values. Plus 1 by 2 when the alignment is parallel to the magnetic field, and minus 1 by 2 is when the alignment is anti-parallel to the magnetic field. Next, what is hyperfine splitting? Discuss how many lines for C6H5NH2 and CH3NH2 molecules. It is a special feature of ESR caused by the interaction of electron spins in the magnetic nuclei in the sample. And for C6H5NH2, N1 is equals to 1 and N2 is equals to 2 and N3 is equals to 5, because this molecule will split into 3 types, that is N separate molecules and NH2 and C6H5. So the values are N1, N2 and N3, and when we apply these values for the 2Ni plus 1 rule, we get 36 lines. Similarly for CH3 and NH2 molecule. And finally, how to differentiate CH3 and CD3 radical by ESR. CH3 and CD3 molecules have different 2Ni plus 1 values. For CH3 it is 4 lines and for CD3 it is 7 lines. Thank you.